Cool. Thank you, guys. Cool. All right, so we're going to get started. I had this up earlier. I think most of you guys probably have this stuff going, but you might not have Docker installed, so that would be the only thing that, and you don't need to do it right now. We can do it at the break. But at some point, you're going to need Docker for the solution. Hello, everyone. My name is Kevin Jones. So I am a DevRel engineer working for Edge and Node. I also am a core member of the Build Guild. So I work on the Scaffold ETH project, supporting that. And really today, I'm going to be talking to you guys about full stack dApp development. So hopefully this is going to kind of arm you to really have everything you need to like build a really cool project for this pretty quickly. That's what Scaffold ETH is actually originally created for, is like to rapidly prototype and build stuff. And then I'm going to also show off our integration with the graph. So we have a special build of Scaffold ETH, or special branch, I guess you would call it, where we're going to teach you how you can build a subgraph as well. The requirement for the hackathon this weekend is not to use to build a subgraph, but it is valuable information for you guys as developers to understand the ecosystem and how to build one. So I'm going to at least show you guys how to do that. So Scaffold ETH, what is it? So Scaffold ETH is a project that is built around a Yarn repo, so a Yarn mono repo. And the concept with Scaffold ETH is it comes with kind of everything you need to build a dApp, right? It comes with Next.js, with TypeScript mostly. It will support JavaScript, so you can write JavaScript. It comes with Rainbow Kit, which is like basically has like the provider hookups for you to be able to connect your wallet if you want to use some kind of like wallet connect or something like that. And it also comes with a virtualized chain that you can run locally. So there's two options. I'm going to be talking strictly about hardhat. I would recommend you guys just kind of stick with hardhat because you guys have already learned it from Mateus. But there is a Foundry version as well. So you can spin up Scaffold ETH with Foundry. The build that I'm going to be using today is the subgraph package, which is only on hardhat. But Foundry is there. So if for some reason somewhere in the crowd there's someone that's hardcore Foundry, then you can do it. WAGMI is basically like a plugin for React, or basically an SDK that allows you to interact with the wallet connection that you have. So we use that. And then also TypeScript. So everything's written in TypeScript. TypeScript is kind of like the way to go this day, like in age, like if you're gonna learn how to build a dApp, I would recommend starting with TypeScript just because it's got the type safety and it's just a little bit more intuitive, but you can write stuff in JavaScript. So don't be afraid if you're like, I only know JavaScript, that's okay. And if you don't know JavaScript at all or TypeScript at all, that's okay too, because the thing that I'm gonna walk you guys through today is gonna kind of show you some basics and kind of help you get around to do stuff. There's a lot of cool stuff that's already in Scaffold ETH that make it easy to build a UI. You don't have to be like a UI maxi. You can actually kind of get away with like at least building your smart contract and then plugging it up to Scaffold ETH. So then the version that we're going to be doing today is the subgraph package, which is kind of the same thing as all that stuff. But then it's also this kind of like middleware layer. So that's what the graph is. The graph is kind of like a middleware layer for indexing data. And I'm going to go more into that and talk about that. But basically you can think of it like this, like blockchains are kind of incentivized for writes, right? So if you want to like secure some data on the blockchain and like update state on something, you sign a transaction and you submit some value. And that security is basically empowered by the value that you're sending in the transaction that pays the validators. And it's really like blockchains are incentivized for writing, but they're not incentivized for reading so much. And in fact, the method that you read from, like a JSON RPC, is actually not optimized for reading. It's really used for managing your node, like if you have a blockchain node. So the indexing layer is kind of a crucial part of the stack, because you need something that can like read all the data from the blockchain and then store it somewhere else. And that's exactly what the graph is. It's a decentralized network. So I'm going to get more into that later, but I just want to at least show that. Okay, so I want to start with just doing a quick overview. You guys don't need to follow along. Just kind of watch what I'm doing so you guys can see the value of Scaffold ETH. And then what we'll do is we'll pause and we'll have you guys set it up, okay? So let's do that. Okay, so I'm using a few terminals. I'm using tmux, which is really awesome, tmux. Tmux is basically a terminal multiplexer. It just allows you to split up your screen. You don't need to use it. You can just have multiple terminals open. So if you see there's 4 and you're confused why there's 4, that's why. But you can just open up separate panels. And that's because you kind of always need a few different windows to do different things. Because it is a yarn package, you run these yarn commands to kind of set up different parts. So first you want to set up your blockchain, then you want to set up your front end, then you want to actually deploy, and then lastly we want to set up Docker. So we need to have these 4 windows always open. So scaffold.eth, if you go to scaffold.eth.io, it will take you to the page for scaffold.eth. There's really 2 ways to install scaffold.eth. You can either clone the repository, which is here. And by the way, these are not the steps you're going to follow today, but I just want to talk about it. You can either clone the repository or you can run an npx command, which is basically like a script that will set it up for you. It's in kind of a beta state, but if you want to use Foundry, you need to use the npx command. I would recommend using the git clone in the future just because it's, I don't know, it's a little bit less beta. It's a little bit more stable. Sometimes there's issues with the npx script, so I would use the clone command. We're going to be talking about, and if you look in the notes today, there is a link to the subgraph package here. And there's also a link to my workshop that we're going to be going through, which is here. And this has all the steps that we're going to follow. And more importantly, what we're going to do is we're going to use this subgraph package of scaffold.eth. So we're going to clone the repository, and then we're going to check out this special branch called subgraph package, okay? So I've already done this for you. So that's why I want to just preface with that. And I just want to show you guys how it works. So we've got it all here. Let's just check real quick. We can see that we have a Git repository. There's a package JSON, which means it's a yarn package. There is a packages folder. Let's look at the code real quick. So I'm using VS Code. And let's look at the packages folder. And we'll see there's 3 different packages. So typical scaffold.eth is 2 packages. It's hardhat and it's Next.js, right? So it's backend, front end. So we're going to be setting up a backend in hardhat, and we're going to be setting up a front end in Next.js, and then we're going to be setting up a subgraph in Docker. Okay. So we'll get more into the code here a little bit and a little bit later, but let's just set it up. So the way you orchestrate scaffold.eth is all with yarn commands. The beauty of yarn package manager is you can set up scripts that make easy to follow commands to do different things. So to set up our blockchain, all we need to do is do yarn chain. It's going to basically start up hardhat for us. It's going to give us these play accounts, right? These ether accounts that with private keys, and it's set to go. That's it. Then in a new window, you need to do yarn start. So that's going to start up Next.js, which is React basically with Next.js on top, and it's going to spin it up and run it on localhost 3000. So this is going to be run locally. This is going to be run locally. Now we have our front end and our back end set up. That's it. Yarn chain, yarn start. Okay. Next, we're going to do yarn deploy. That's it. So yarn start, yarn chain, yarn deploy. So with those 3 commands, we basically took a smart contract that comes with scaffold.eth. We deployed it to our hardhat node. Our front end automatically reconfigured for us, and you'll see the magic now. So let's go to our web browser, and let's go to port localhost 3000. So we have our front end, right, running on 3000. And what's cool about scaffold.eth is it does come with a smart contract that's like a very basic smart contract. And we'll see here that we're on the wrong network. We can disconnect. Actually, when you guys set it up, it'll look like this. So it'll automatically connect to what's called a burner wallet. So we'll get to that in a second. But basically, we have this first homepage, which is like kind of like the welcome screen. It's your page. So it uses Next.js app router. So there's a page.tsx file basically, which is like kind of like an index file that has this main page. And then there's these special routes. And the first route is what I want to talk about, which is /debug. right here. So debug contracts. What's cool about scaffold.eth is it actually takes in the smart contract, and when you do a deploy, when you use hardhat deploy, you basically take your smart contract and you compile it down into bytecode and you push it to the blockchain, right? But you also generate what's called an ABI. I don't know if you guys got into ABIs the last couple of days, but the ABI is just basically the instructions so that anything binary talking can interact with your smart contract because your smart contract's compiled, right? So what scaffold.eth does is it takes the ABI and it automatically injects it for you into your front end. So it automatically knows how to interact with your smart contract. So we get our contract address, we have a balance checker for our contract, we have the network that it's configured to, and all of the read and write functions, and we also have our variables, all available to us because scaffold.eth, that's why it's so cool. It just reads all this data in for us. So at this point, we can actually start interacting with our smart contract if we want to. So we could say like, all right, we want to set a greeting. So we can see here that there's a write function that allows us to write state, right? That says, all right, well, let's set a greeting. Right now, it's building unstoppable apps. So we could change it to urbe.eth and then hit send. So you're going to get an error. All right, I don't have enough funds to pay for the transaction. I'm using this burner wallet, which is right here. What's cool about scaffold.eth is the next part is it comes with this burner wallet function, which basically is a private key that's generated inside of the browser. So you don't need to connect any wallet, MetaMask, anything. The wallet's ready for you already. All you gotta do is fund it. So there's also a button for that. So we hit that, we fund the wallet. So now we have 1 ETH in our wallet, ready to go. Now we can hit send, and we can update the state. So it's that easy. We just up and running with 2 commands, deployed our contract, made a state change. We can see here now that we have our new greeting. We have an owner variable, which we'll get to in a little bit. We have a premium, which is like a Boolean that's being checked. We'll get to that in a second. And then we have a counter that keeps track of how many times the greeting's been set. So if I come over here and say foo, and then I say bar, and it keeps going up, right? So it's a smart contract. It's very basic. I'm not gonna get to the subgraph section yet because we're not that far. But what I want to do now is have you guys kind of get to this setup where you at least have scaffold.eth running and you're good to go. Really quick too, let me just show off the smart contract so you guys can see what that looks like. So the packages folder, again, it's got 2 different folders or 3 different folders. The hardhat folder, the Next.js folder. First half of today, we're just going to be focusing on hardhat, so we won't get to the Next.js till later. So let's look at the hardhat folder, and let's look at the contracts folder. So inside hardhat contracts, we have yourcontract.sol. There's a lot of comments in here that kind of make it easy to read and understand what's going on. But basically, it's a solidity file, right? And it's got the pragma version. It's got some variables that we've defined that you saw earlier that are here. We have an owner variable, we have the string, we have a Boolean, and then we have the counter, and then we also have this mapping, which there's a lot of different stuff going on in here. And then there's also events, okay? Events are basically like logs. So I don't know if you guys got into that much, but events are important because we're gonna use that in the scaffold or the graph part of today's workshop. But the event is what's broadcasting all the information that changes. And then we have this constructor. Okay, we'll get to that a little bit later as well. But the constructor is just like any constructor if you're familiar with JavaScript. The constructor in Solidity's case only runs at the time that the contract is deployed. So we can change whatever we want at that time. Sorry, this is kind of going in and out. And then we have these modifiers, which we'll get to that a little bit later, but that's like a check basically. A modifier is a function, but it's just called a modifier because you can run it as a requirement for another function. But anyways, you get the idea. It's a really basic smart contract. You can, Solidity is pretty easy. Anyone who's written some programming language probably can learn Solidity pretty quick. So you guys can probably glance at this and kind of make your own decisions. But let's kind of go into the setup. So today we're going to be following the subgraph package full stack dApp workshop. So it's a repository. You can go to bit.ly/fullstackdApp okay? And that's going to take you to my GitHub. I'll leave this up for a second. So bit.ly/fullstackdap. There is a video, so if you guys for some reason get lost today and you guys want to follow along later, there is a video here which will walk you through everything that we're doing today. It was recorded in San Francisco, but we're going to actually go through it. So when you go to the repository, basically there's the requirements. So you probably already have Node.js installed. You probably already have Yarn Package Manager. You probably have Git. If you're a developer, you gotta have Git, right? But the last one is Docker. I should put tmux as a requirement here, but it's not. So Docker, raise of hands, is who here has never used Docker before? Okay. Don't be afraid because you don't need to know Docker. The main thing about Docker is it has the package that we have in here, it has a Docker compose file that does everything for you. You just need to have the Docker binary installed on your machine, and you can run Docker compose and install it. Raise of hands, who here is using Linux? Okay, who here is using Windows? A lot of Windows. How many are using Mac? So mostly Mac, okay. So Mac is the most user-friendly experience for Scaffold ETH, but there are some like caveats with Windows, and there's some caveats with Linux. Hopefully we'll just address those as they come. But so you guys can follow along. So what I want you guys to do is if you don't have Docker installed, install Docker, okay? If you've got Docker installed, you can start with this first step. So you can come down to here where it says Setup Scaffold ETH Subgraph Package, okay? And what we'll do is I'm actually gonna go through it with you guys while we do it. So you guys can watch me if you want, or if you guys have issues, then we can address them as they come up. So I'm just gonna go back here. cd rm-rf sc2. Let me just wipe everything out. So I'm just wiping everything out. rm-rf, goodbye. Okay, so I'm gonna do this, and I'm gonna copy, paste it in. I'm just gonna make the directory name a little shorter because I should have done that in my demo, but I'm just gonna do se2 like that. That way it's easier to read when you guys are looking. So I'm just gonna check out the repository. We're just gonna go through it one more time real quick. Okay, cd se2. Now, the thing you guys didn't see me do earlier is yarn install. You can type just yarn, or you can type yarn install. So it's gonna go and install the dependencies. So, you know, there's a lot of stuff, there's a lot of packages that come with Scaffold ETH, so it's not the most lightweight developer experience, but it's a lot lighter than it used to be. So Scaffold ETH 2 is the new version, Scaffold ETH 1 was a lot bigger. Scaffold ETH 2 is actually pretty lean, but we're gonna install those dependencies. Might take a little while. If everyone's downloading the packages at the same time, it might take a little longer, right? Because we're probably chewing up the internet speed. So we did yarn install, so first we cloned, then we did a yarn install. Now we're gonna do yarn chain, right? Oh, if I can spell right, yarn chain. And then we're gonna do yarn start. Oh, gotta go into the right directory. Yarn start. And go into this one. And next we're gonna do yarn start, then yarn deploy. So yarn chain over here, yarn start over here, yarn deploy down here. So again, these can just be in separate windows, but you always want to have kind of like 3 or 4 windows with Scaffold ETH. There we go. We deployed successfully. Now the last one is we need to set up. So if you've, show of hands if you got Docker installed. Okay. So if you're not, I assume anyone else is still installing Docker, right? Yeah. Okay. So while we're waiting for people to install Docker, I'm just going to finish up here with this last couple steps. So yarn start, yarn deploy, yarn chain, yarn start, yarn deploy. This last window, we're going to start up the graph. So that's this step, set up the graph integration. So when you do these first 4 commands, you'll be up and running with scaffolding 2. Now what we're going to do is set up the graph. So yarn run node will do that for us. There's a command here to do clean node. You only really need to do that if you've set this up before. We're just going to do yarn run node. So this last one is Docker. So basically you can think of Docker as like an orchestration tool for virtualized containers. So virtual machines, containers, whatever you want to call them. Containers are just like little small versions of either an OS or a binary package, and they're running locally. So here we're running all the infrastructure for Graph in this kind of like virtualized environment inside of Docker. You'll know that everything's going good when it says info, downloading latest blocks from Ethereum. So if you're able to see this here, that means you have your blockchain running. If you see this say ready, you have your front end ready. If you have successfully generated your types and deployed to the transaction with the deployment, and it tells you how much gas you got, that's successful. And if you see info downloading latest blocks from Ethereum, then you know that's set up successfully. Okay? Still running? Yeah, so everyone's probably trying to install the packages right now, so internet connection might be a little struggling a little bit.
Is it normal, this error?
You're just trying to connect to like the blockchain? That's just the blockchain. How did you get that? Where's your terminal at?
Yeah, it is this one I use.
Oh yeah, that's good.
Virtual subsystem for Linux.
Yeah, that's fine.
Okay,
hardhat's running.
Yarn chain and then
yeah. Yeah, that's okay. Yeah, so now open up a new terminal. So now you need a new terminal, and now you can go into the same folder and do yarn start.
Same folder.
Yep. Yeah, wherever you checked out scaffold.eth. So. Yeah, so if you're following the instructions, it's going to be inside of this folder, scaffold.eth2-subgraph package, right? Okay. Yep, so the next command is yarn start. So that's going to need to be in a new window. And then yarn deploy is also in a new window. I'm going to go ahead and leave this up for a second. Yeah, it's just loading up your browser. Just give it a second. And then in that new window, do yarn deploy. So another terminal. Yeah. So again, you really need 4 terminals open to do all this stuff. You guys are going to become multitaskers. But yeah. Anyone stuck? This is kind of what it should look like if you're up and running. Yeah.
How can I set up my terminal like yours? I would really like to.
It's called TMUX. TMUX. Yeah, TMUX. Yeah, it's kind of hard to use. I'll be honest, but once you learn it,
I've tried,
you'll be an ultra elite hacker.
Yeah, I've tried, but it doesn't really look like
It is. Yeah. So there's a lot of shortcuts.
Yeah.
To it. We can chat later and I can give you some ideas of how you set it up properly. If you memorize the shortcuts for like the basic stuff, pretty easy. Yeah.
Okay. Just like the split screen.
Yeah. Mm-hmm.
That's the thing.
Yeah, so you can do like Control B, Shift 5, or like Control P, Shift comma, and you can do these things to split the screen up and.
I was looking at the internet and it looked confusing.
Yeah.
I
Hey.
will
Yeah, we can chat later. I can show you.
And we have to clone this one, not the
Yeah. So you might want to just go to bit.ly/fullstackdapp. So go to bit. Yeah, go to the URL right.
That's one.
No. Actually, it's right here. There you go. Yep. Follow that one. Yep.
I think it's displaying Docker compose goes like this with a dash. But I remember when I installed, for some reason, mine is without a dash.
Okay.
Where is
Are you running Linux?
Yeah, WSL. Where is the script so that I can change it?
Yes. Who here is running Linux? Few? Okay. You guys might want to pay attention to this. So I mentioned briefly that Scaffold.eth is a monorepo. So it's a Yarn monorepo. So you have a package JSON which has all the scripts here, right? And they reference the monorepo scripts. So because there's workspaces, so inside of the packages folder here, we have a hardhat, and then we have another package JSON. So then these are the scripts for this one. So if you're, in this case, we're using the subgraph package. So we can go to that package JSON, and we can look at the command that's being run when we do run node. It's doing here, cd graph node and docker compose up. So if for some reason you've installed Docker and the command for Docker is not docker-compose for Docker compose, it might be docker space compose. You might have to edit this. So there are these weird little caveats with different operating systems. I apologize, but we'll try to work you guys through if you have issues. But that's important to understand that, you know, that's kind of how the monorepo works. Main package JSON is here, and it has all of the scripts for you, and that references the other workspaces that you have right here. So if you're trying to troubleshoot something with a yarn command, that's where you go. Okay, anyone else stuck?
But here it says method not supported.
That's okay. Yeah, that's normal. That's like I don't know why it's doing that, but it does that lately. Something to do with EVM, but yeah, you should be good. Yeah. Okay, is anyone else stuck? Okay, raise of hands if you have gotten to where I was at. A few of you guys? Okay. Raise of hands if you need like some more time. Yeah, okay. Cool. Yes. Seem to compile. Maybe it already failed to get chain ID following back on net version. Cannot connect to the network local host. That's weird.
I connected to, I put yarn star. No, this is yarn star.
Oh.
No, it's okay.
That one's running.
Yes. It's running.
Is it running in Linux?
This was a Windows subsystem in Linux. This is this is virtual code that is connected with the WSL, that is the virtual subsystem.
Yeah, I feel like it's not able to connect to Linux localhost for some reason. So let me think real quick.
I can do Windows, but I don't know if it's the same.
Yeah, so in my workshop, I describe a bug here, which is with the chain. So here it is. Okay, so if you need to open up, is this on? Test 1, 2. Okay, so if you're running Linux, you need to go into your package JSON for hardhat. So you need to go into hardhat, so packages hardhat, package JSON, and then you need to look at the chain command here. So because if you're running if you're running Windows, yeah, with Linux, there's a weird issue with networking where you have to broadcast on 0.0.0 to be able to access it inside of other networks. I think on Linux too, yeah, let's figure it out as we go. If you have an issue where you see like unable to connect to hardhat, it might be because you need to add this command. So it's in the workshop. If you scroll just a little bit further to this part, and it's the hardhat node -- network hardhat no deploy, and you need to add this -- hostname 0.0.0.0. So try to add that to yarn chain and then restart your chain. So you're gonna have to rerun yarn start or yarn chain, sorry, after you add that. So you can come in here, you can add it to the back of chain like this, save it, make sure you save the package JSON, and then restart your chain, okay? So again, that's in the README. It's going to be, you've probably done this part. You did the install, you did a chain, you did start, and then we did the deploy. And then now you want to set up the graph, right? As you can see, it's running. It looks like it's working for me. But we have this run node. You might get an error about that it cannot connect to Docker. So then you need to add this host name right here to this package JSON and packages hardhat, okay? And then you need to make sure you stop down and restart with yarn chain. You also might need to allow firewall access. So if you can, this is not best practice, but turn off your firewall. Turn it off for right now. No one's going to hack you. Just turn it off. We're in a secure environment. We're all friends. All right, is anyone stuck? Anyone stuck? No? Just people who are still working, yeah? Oh, cool. Awesome. Cool. So raise of hands if you think you're good at this point. Downloading latest blocks. Is anyone? I saw a few people. Okay, so people are still thinking. Is it working? Okay, awesome. All right, is anyone stuck? Anyone stuck? No? Raise of hands if it's working. Okay. So some of you guys are still working. You need more time? You need like 5 more minutes to, yeah? Okay. Yeah, that's, yeah, that should be good. I think it's good. I think that's right. Yeah, that's right.
Has been one command that didn't get. Clean node.
Yeah, that's okay. Don't worry about it. That's for like later. If you want to restart everything, you need to clean up all the old data.
Okay.
So it kind of wipes out your data. I'll explain it right now. So just so you guys know too, there is this yarn clean node command right here, yarn clean node. That just basically is cleaning up old data. So let's say that you've made changes to your smart contract and you want to wipe out all of your graph node data. That's why you need to do that. So the first time you guys don't have to worry about that. We'll worry about that when we get to it. Yeah. Either one. Whatever you like. What do you prefer? Yeah, I like doing it in my own terminal because... Oh, sorry. I'm sorry. I don't like the VS Code terminal, but that's just my preference. Are you using Windows, yeah? So you need to be, is that Linux inside of Windows? Yeah. I haven't seen that. Oh, Yarn not installed. You need to install Yarn. So Google install Yarn. Yeah, you need to install Yarn Package Manager.
I have Linux.
Uh-huh.
What file I have to modify?
Oh, it's the package JSON inside of packages hardhat.
So you have to do this before?
Yeah, don't worry about that. We were going to worry. Yeah, well, you can kind of skip that command. Yeah, so if you load up the, okay, looks like you got a deploy working, okay, cool. Yeah, so now open up the project. You have like, you do use VS Code or use Vim or what? So go to packages, go to hardhat, and then go to package JSON. There you go. And so it's the chain one. You need to add the host name. You guys good? Okay. Okay. All right. We'll let everyone catch up because I think it's important that everyone's caught up. So if you get stuck, let me know. We'll give it like 5-10 more minutes.
I'm inside this folder from the terminal, and I try to run this command. There is this one, so you can see it. I guess the right one. And when I try, it says it already has everything inside, but it's empty. So I create another one, but I just clone this one, not that command.
Oh yeah, you did this one, yeah. Because it's called subgraph package. It's actually named different. Yeah, because I think I had you name it something else, don't I? Go in my README. No, it's the same. It is the same package. You can use it, but I have you name it scaffold2-subgraph package.
To rename it?
No, I'm telling you that's what I had you check it out as. So it shouldn't be existing. That's what I'm trying to say. So here, let's do this. Load up your terminal. Where's your terminal at? Over here. Oh, you don't need to do that. You can just do it. Yeah, do it here.
So / I'm inside all this folder.
Okay. Yeah. So now we can do just paste what you just copied. Yeah. Grab that.
This one because the other one doesn't work on Windows.
Let's try it. Already exists. It's on interjector. Here, let me see real quick. Here, let's do this. ls. Can you move this over so we can see it?
So in this folder, urbe.eth and bootcamp, this one, there are 4 other folders. Okay, and maybe inside this one,
something weird's going on with that.
I guess it's this one, but it's only
It's something with the naming, like it doesn't like the extra dash or something. Try doing it like this. Here, paste it in again. We'll go back to the folder, the root folder.
Maybe I can do something different. This one time, another.
Okay. You had a question? See if you can try a different folder. Yeah. You had a question?
He observed that your terminal, the one where you ran your install, updated, while ours just
No, that's okay.
Process.
No, yeah. Okay, you had a question?
I have a problem. So I've done blah blah all this part, okay, and start this. I have problems, so I've done this.
You did that, yeah.
I did that. So here, okay.
Yep. You saved it, yeah?
Yeah. It's all
Okay.
okay. And after yarn chain again.
Yeah, you got to restart your
I
chain.
restart everything. Restart.
Okay.
And do everything. Do this. And try this.
Okay, don't worry about that because we're going to get to this in a second. So,
okay.
Well, show me what you got though. You get an error or what?
Yeah. So this is.
It's probably because
yarn start, and then I've done the.
Deploy.
Yeah, the deploy actually.
Yeah.
So it's okay.
Yeah.
But after when I do.
Run node. Oh, Docker Compose. So, do you have Docker installed?
Yep.
Do you have Docker Compose installed? You might have to download Docker Compose. I'll mention that right now. Yeah. One sec. All right. If you guys are having issues with Docker Compose in Windows, sorry. Obviously, I can't type and type my password at the same time. Install Docker Compose. So do a Google for like install Docker Compose Windows Linux subsystem. You might need to install Docker inside of Linux so that you have the docker-compose command. So it's probably here. Yeah. So these are probably the steps you need to follow. That's if it's on Ubuntu. I think it's Ubuntu, yeah? WSL? Ubuntu WSL, right? Is that the version of Linux, do you guys know? That comes with Windows? It's Ubuntu, right? Yeah. So this should work. So if you Google that, just Google like install Docker Compose Windows Linux subsystem and make sure you have the Docker Compose command. You can verify by just doing like docker-compose-help and see if you get an output, or --version, that would work too. But you need to have the docker-compose available if you want to use Docker. And we need to use Docker. If for some reason, worst case, you've at least been able to deploy your contract using yarn deploy, that's the biggest important thing. If you don't get the Docker running, it's not the end of the world because it's not part of your bounty, so you guys can skip that part, okay? Yeah.
When I try to modify this thing, when I send, it say.
That's weird. It's not reading anything. Oh, you know what? Did your deploy work? Yeah, it did, right?
Yeah.
That's weird.
See, this is my.
It seems like React can't reach.
This is change. This is start.
Do yarn deployed over here. Yarn deploy space -- reset. No, -- sorry. Try it again. You have to put something in there. Oh, it was working now. Yeah.
Okay, thank you.
Yeah.
And I have to do this.
In a new window, yeah.
In a window, it's okay if I do it
Yeah.
like that. Okay.
Yeah,
But
so yarn start.
start.
Are you in the right directory though? Yeah, there you go.
Oh, no, it's fine.
Yeah. You just have to be in the same directory that you had scaffoldeth.
Okay.
And then open another one.
So now another one for Yarn deploy.
Yeah.
So
Yep.
for the-
Yeah. Let me know if you get stuck. Okay. Yeah, you have one more question?
So I installed Docker Compose. And
Now it's working?
This is yarn local create and show me this error. So
Let's worry about it after I get to there, okay? I'll see if I can figure it out. Yeah. Let's figure it out when we get there. I think, yeah. Okay. Raise of hands if you've gotten your contract deployed, your smart contract. Okay. Raise your hand if you've got Graph node running in Docker. Okay. Raise your hand if you're completely stuck still. Stuck. You're stuck. Okay. So a few people. And it's still playing catch up, yeah? To do yarn install? Yeah, that's okay. That's normal. Okay. That's okay. I think what we'll do at this point is we'll let people catch up on their kind of intermediate time. I'll help people as we go. But let's kind of go into the next part. Yeah.
We are in the right condition if we match the three.
Yeah.
Okay.
Yeah, so let's think about this like a test. This one is worth 25%. This one is worth 25%. This is worth 25%. This is worth 25%. If you're getting 75%, you're a C, and you're going to qualify for the hackathon. If you're failing on this part and Docker's not working because you have Linux and Windows, we'll try to get you up and running, but don't stress about it, okay? What we want to focus on now is these three things. We're going to talk about the graph, but if you've made it through these three and you've got these up and running, you're able to do a deploy, you're golden, okay? If you're having problems with Docker, that's okay, and Graph Node, that's okay. You're going to learn something today, but don't worry about, don't worry about it. Okay, so let's have everyone kind of listen in now. Okay, we're going to go to the next section. Okay, I want to talk about the graph first of all. Okay, so the main concepts for blockchain, right, are blockchain smart contracts, front end, decentralized front ends, right, static content like HTML, JavaScript, CSS that can be deployed on a decentralized file sharing protocol like IPFS or Arweave. Okay? But the other part, the data, is one of the hardest things to solve because there's lots of data, right? I think we all know that in information systems, in general, there's just a lot of data. So you can't store this data on chain, right? So if we know about smart contracts and the basics of what they're doing, we'll talk about Ethereum because this is an Ethereum hackathon. Ethereum is an Ethereum virtual machine. It is a state machine. The main purpose of Ethereum is to deploy smart contracts that have a state and then allow them all to come to consensus on changes to that state, okay? So smart contracts, if we look at like an example like CryptoPunks, right? All it is a state of IDs. So all the IDs that are CryptoPunk NFTs, what their current owner is, which is also a state, what their metadata URI is, which is, you know, NFT lingo, which you don't need to know, but that's like all the aspects to each individual NFT, where that lives. But really all an NFT contract is 3 different things are going on. There's transfers, there's approvals, and there's owners, like, you know, there's some state inside of the NFT contract. But really, it's just a data object, right? So we try to just put exactly in a smart contract what should sit in a smart contract that's like important for security. So like an NFT, a CryptoPunk, who wants one? Anyone want one? I'll send. But they're worth like, I don't know, 100 ETH or something. I don't even know. But my point is that like the owner is very important because if you own the NFT, you own like the 100 ETH that it's worth. So that's something you want to put on chain. The metadata URI is probably not as important because it's like the picture and it's like the traits of it. You know, yeah, it is important for it to be somewhere, but it doesn't need to be on chain. So anyways, this stuff changes, right? Like state changes, just like any database has database entries that get updated. State changes. You propose a transaction to transfer a CryptoPunk. Like if I'm going to send one of these guys in the stage, a CryptoPunk, I'll send it to you. That gets initiated on the blockchain, and what happens is an event is created. Like an event says, okay, cool, this person approved this transfer and transferred it to this person for maybe you transferred it to an exchange to sell it, or maybe you transferred it directly to someone's wallet. Either way, an event is triggered, okay? So that's important, but there's a couple problems with blockchain data that we're trying to solve with the graph, and the first one is there's a lot going on. There's like so many people are competing for block space, right? There's tons of these dApps, these protocols, smart contracts, transfers going on. There's all sorts of stuff, and it's very difficult to read because it's all usually in like bytecode. It's very hard to understand. If you were to look at like the block and like download it to your computer, you'd be like, I just don't know what to do with this. So that's the first problem. It's messy. The blocks are messy, and there's a lot of them. The other problem is, I talked about it earlier, is blockchains are not incentivized for reading data. They're really incentivized for writing data, okay? So if you want, let's say you wanted to read all of the CryptoPunks. There's 10,000 of them. You would need to make 10,000 separate calls for each individual CryptoPunk, and then you got to have some place to store that. So you'd have to have your own database, or you'd have to have somewhere to put that, and then that's only going to give you the current state. It's not going to give you historical state, right? So that's some of the problems that you have to deal with. Making 10,000 JSON RPC calls to the blockchain would take a long time. Like it just doesn't make sense for you to do that in your front end. So that's a problem. Also provenance, I talked about this, is like you can't really know like what happened at any particular point in the blockchain unless you query that exact block. So that can be really messy to deal with because you have to know the exact block number, which block numbers are numbers, and they have a timestamp kind of related to them that's somewhat accurate, but it's very hard to get the data you care about in that, you know, going back in time. So what we see is like stuff like this, where it's like people are trying to get, like in this example, it's someone's trying to use their front end to get an address from the wallet, loop through all of the NFTs in the person's wallet, create an object on that, push all the data into that object, and then print that data out. So This would basically be fine if the user only had like 1 or 2 or 3 NFTs, but the minute that they have like 20 or 40 or 50 NFTs, each NFT would maybe take like 100 milliseconds, right? You can see the problem here. The page time would just drastically, performance would drop. So this is a real actual person that was trying to do it this way. It was not ideal, right? So this is where the graph comes in. So the graph is, it's a separate kind of network, decentralized network of indexers. That's all they do, is they index data and make that data available to consumers, okay? So it serves about 1 billion queries per day, but the idea is to take that same mess of like all the blockchains and organize them into separate buckets, like databases, called subgraphs, okay? So a subgraph, that's exactly what a subgraph is it's an organized data for a smart contract, right? Or a set of smart contracts. So what we can do is, the graph is powered by GraphQL. Who here has used GraphQL? Okay. GraphQL, no? Okay, GraphQL is awesome, first of all. I mean, we are in Facebook Meta, so they're like the creators of GraphQL. It's a query language that allows you to specifically query for exactly what you want. So if you only care about the NFT's ID, token ID, the metadata, and their previous owners, you can specifically ask for that data and you will get only that data back. So it's a query language that is highly customizable and highly performant, right? It's optimized for front ends because you can just get what you want and then you don't have to like do this like crazy parsing and filtering inside of your app. You just filter based on requests. So this is what we want to build with subgraph package. It's just the same stack. It's Next.js front end, blockchain and hardhat or Foundry, and then indexing protocol is the graph, which in this case we're running everything in Docker. Okay. So what is a subgraph exactly, like technically? So this is probably a little bit more deeper dive. And the main idea is that there's really like 3 configurations to a subgraph. The first is the manifest, which is kind of like the main configuration file. It's basically telling you exactly what network you care about. So if you're on a connect to Ethereum, or in this case Arbitrum, and then also what protocol you care about or what dApp you care about, what smart contract. So in this case we have like Uniswap, right? And that defines like where the data sources come from and what you want to actually query. Yeah.
If this it contains like the API of the contract we're going to.
That's a great question. Yeah. So the manifest also does read in the ABI because just like our front end needs an ABI to be able to interact with it, like that's what Scaffoldit does. The graph also needs an ABI because it needs to be able to decode the data as it comes in. So that's a great question. And we'll look at this a little closer, but that does have the ABI in it. The next one is the entities. So I know GraphQL is new to you guys, but the way you organize data in GraphQL is based off what's called entities. So entities are basically like key value stores. So like data types and how you want to store those. So the graph is powered by Postgres and GraphQL. So all the data is stored in Postgres and exposed with GraphQL. And so if you want to store this data in a specially organized way in a subgraph, you have to define exactly what data types you care about and how they should be stored in what structure. So that makes you able to, your schema correlates directly to how you query data and how you receive data in those kind of objects. And we'll get closer into it. I know this is probably a little deep, but we'll actually show it in the real world. And then the last part of a subgraph is the WASM module. Who here is familiar with WASM? No. Okay. So WASM is just WebAssembly. So it's compiled down, optimized code. I would say that like secure-wise is very secure. And particularly a subgraph, the WASM module is written in assembly script, which is a subset of TypeScript. So it's basically TypeScript. Like if you look at it and you understand TypeScript or JavaScript, you can understand what this is. And this is kind of like, I call it the runtime. This is what's like processing all the data. So these three files together are deployed on the decentralized network. So the graph is a decentralized network. There's over 200 indexers that are running all over the world. And if you deploy a subgraph, you take these three files, you package them up, and you send them off to the graph. All these indexers say, okay, cool, I'll pick up these based on whatever incentive that they have, which I'm not going to get into any of the tokenomics around GRT or anything like that, but I just want to talk about the technical functionality. And these are what you need to build a subgraph, okay? Any questions about this before I go on? And I will, again, preface this. This is kind of like a learning module for you for the graph. You don't need to use the graph in your project, but this is all really good information, especially if you guys are going to stick to Web3. And the graph is really, really useful. Any questions? No? Okay. So the basic concept of the graph is basically to take event data, so logs, right? Things are going on inside of a contract, we care about that data. Or maybe you have off-chain data. So maybe you're storing stuff on something like IPFS or Arweave, which are both decentralized file sharing protocols. So you might have like static files, like maybe you have a JSON object that you store in Arweave, and you want to ingest that into the graph. Well, you can do that with data processing with the graph, because you have your assembly script, which is your WASM module, that basically listens for these events or can query these decentralized protocols and then take that data in, process it how you want, right? Customized here in assembly script, and store it in Postgres, right? So that's what the indexers are doing behind the hood. And then the consumers, right, that want to consume that data, they make a GraphQL request with exactly what they care about. Graph node, which is part of the decentralized network, it's basically an operator that runs on the stack, does a query against the data that's been stored, gets the response, and serves it in GraphQL. So here on the back end, this is all done behind the hood. It's SQL. But for the user, they get that pretty cool experience with GraphQL where it's easy to read and write, or easy to read. So again, 3 configuration files mainly that you need to deploy a subgraph. All the processing is done with WASM in this kind of runtime environment. Events are stored off-chain, events are pulled from a chain, processed with the assembly script, and stored in Postgres. And then for visualization for the front-end consumer, this could be a dApp. This could be a front end like we're building with Scaffold ETH. Or it could be like some kind of data scientist, right, that wants to get interesting data. It could be anything, any kind of consumer. And then the data is stored in Postgres. Any questions? Does it make sense? Yeah? Yeah.
On the first slide, please, the last word refers to a schema.
The manifest?
Where is the...
This one?
Last one?
This one?
Okay. It translates data from your data sources to the entities defined in the schema, so in the manifest.
Mm-hmm. Yeah, so you can think of like this manifest as kind of like, it's a YAML. So everyone knows, like, who knows YAML? YAML's cool because it just like organizes like configurations for you, right? So like that's exactly what it is. It's like, okay, I care about this network, I care about this smart contract, I care about these data types, and it references all the entities in here. And it also references all of the processing in here. They're called handlers. They're called handlers.
Defined in the entities.
Mm-hmm.
Okay.
Yeah. Yeah.
If I understood correctly, we define where the data, where subgraph will read the data, and we just request to subgraph with the queries.
Mm-hmm.
And the data that will be read is from the blockchain.
It's originally from the blockchain, and then it gets ingested into the graph.
And then subgraph starts indexing all the stuff,
Mm-hmm.
and then we can use it.
Yep.
That's pretty cool.
Yeah, it's very cool. That's why I work here. Okay, so let's show it in practice. Oh, one more thing. So this is kind of this like same idea I talked about earlier. So you have a dApp, right? You have your decentralized application that's maybe you're probably running in like IPFS or Arweave. You still propose transactions to the blockchain by signing it with a cryptographic key and making a call to your smart contract. Your smart contract fires off events, which are like logs. Graph node is like the workhorse for the graph network. So this would be an indexer running graph node, picks up your configuration, listens to the events, it runs the WASM module, stores that in Postgres, and then your dApp just queries the API, right? That is also exposed through graph node. Does that make sense?
Yes. So the events guarantee that the stores are always updated.
Mm-hmm.
Okay.
Yeah. You have a question?
Graph node listen to all the events that happens or only the one that are configured?
Only that are configured in the subgraph. So, yeah. So imagine like, and I just want to give you an idea of what, like, if we look at like the graph, if we go to like thegraph.com and we go to products and we go to Explorer, someone name a protocol. Does anyone know a Web3 protocol? Uniswap. Okay. No, it's the first one. They're our biggest customer, I would say. So there's already a subgraph for Uniswap. Someone has written it already. There's all these different versions. You can query it directly by using the network. So there's an API for it. You have a query URL. You can generate an API key, and you can query it. It's already set up. But there's a playground here that shows what the data looks like. So I can hit play. So here's my query. So in this case, I wanted to get all the factories, or I should say, I want to get the first 5 factories that are available and the bundles, and then it gives me the data back. So it's query, exactly what I want, exactly what I need with that query. I know this is hard to read. Let me just zoom it in real quick. Does that make sense? So that's the power of GraphQL, and GraphQL runs on the graph network. Like that's what we use.
What are we seeing here? What is ID?
So what we're seeing is, so the ID is probably, it's a good question. It's probably the smart contract address for another protocol. In this case, you can set the ID to whatever you want in the subgraph configuration. If you want the ID to be someone's name, you could figure out a way to do it. But the ID in this case is probably a smart contract address.
I think it's Uniswap.
It's a Uniswap factory address. So the way Uniswap works is it's like it's a contract, and then it's a subcontract that is deployed through the factory. So if every time there's a swap on Uniswap, there's another factory is created, or another smart contract is created. So this should be the address for this particular factory. We could look it up and see what it is, but it's probably some kind of pair or something like that. Okay, anyways, I just want to show you what that looks like. You can also see if it's up and running and all that good stuff. But let's continue on. Let's get our hands dirty a little bit more, okay? So I want to do a quick check. So who here is stuck? Anyone stuck? No? Cool. I know we haven't gotten to that part yet, so let's just try to go there first. Is anyone stuck? No? Okay. Let's just continue on with the workshop, and I want to show the next step. So we've gone ahead, we did the clone, we did the install, we did the chain, we did the start, we did the deploy. You may not have gotten to this part, but if you did,
Yes.
run node, hopefully you got run node working. If you had Linux, you probably had to update this host name to this package JSON. You may have had to open up your firewall. If you haven't done that, do that if you need to. But now we want to talk about our subgraph. So let's go back to the subgraph configuration, or the package. So we showed the contract here, right? And more importantly, what's important is the event, right? It has an event. It's called the greeting change. So every time we change the greeting, it shoots off who sent the greeting, what the greeting was as a string, whether there was a Boolean, true or false, and whether it had any value. So did it have any value in the transaction? Because you can send a transaction on a contract that doesn't have value, or you can. Anyways, okay, so we have an event, and if we look down here at the greeting, we also emit that event. So that's how events work. You define an event, and then you emit the event when something happens. So we want to emit that event, which we do, and cool. But as a front-end developer, how do you get access to that? Well, you would have to, if you didn't use the graph, you would have to go and query the RPC over and over and over and over to get all the events. So it's fine if there's only a few events, but you have hundreds of users, thousands of events per second. It's not going to scale. So this is where the graph comes in. We've already talked about that. So now let's look at the subgraph. Okay. So out of the box, the subgraph has everything that you kind of need to get going. Basically, it's already written for you. So that's important to know because we can look at the subgraph YAML first. So I talked about this earlier. It's called the manifest. So it has the address, which is what is deployed earlier when you did a yarn deploy. It automatically pulls it in. The network is localhost because we're running everything on localhost. And the entities are here, greeting and the sender. So in this case, that's the cool thing about GraphQL is you can create as many entities as you want and store them however you want. So in this case, we're keeping track of all the greetings as one object, one like database table. We're also keep tracking all of the senders as another database table, and then we can link them together, which I'll get to that in a second. Then we have our ABI. So the ABI, we talked about earlier, is kind of like the map to our smart contract so that it's human readable. So if you want to be able to like understand what's going on, we have that injected automatically. And then we have the event handlers. So this is the mapping, the WASM module. So it points to a specific event. So we already showed the event earlier. It's called greeting change. And it has an address, a string, a Boolean, and an unsigned integer. And then it has this handler. So basically what the handler is like, all right, every time this event happens, run this or do this, okay? So as you can see, this is telling our subgraph exactly how to behave. It's telling us where to look, what events we care about, what data types we care about inside of the entities, what kind of WASM we're gonna use, what kind of API version, all that stuff, right? It's pretty much the high level overview of our configuration, right? Then, if we, yeah.
So the sender here is the wallet that is actually emitting the event after.
Yeah, it is, yeah, because if we look at the packages hardhat contract, and we look at the event, it is the, right here, address greeting setter, and then we go here, it's the message sender.
What is indexed? Indexed in the event?
What would it index it as? We'll show you in a second. Let's get there, yeah. So, okay. So we showed the subgraph YAML. Inside the source directory, there's two files, okay? There's the schema and the manifest. So we already did the mapping. Let's look at the schema real quick. So in our case, I talked about earlier, GraphQL, we can organize the data how we care about. By the way, this is highly relevant to Web 2 stuff. So if you guys are even going to get a job in Web 2, this is very important. We can organize our data however we want based off the data types. So in this case, we have a type called greeting, and we have a type called sender. They're both entities, which means they're like database tables essentially. And they all have all the data types defined with their keys and the value, right? So we have an IED, sender, greeting, premium, value, created at, and transaction hash. The key thing here is our sender list, which is just a database of all the people that have signed transactions and sent the greeting, has this greetings object here with the derived from field. So derived from allows you to create a relational link between two different data type or two different entities. So here we can link these together so that if we query this sender, it will give us all the greetings he's ever done in a database lookup, all through Postgres. It happens in the back end. It's very efficient. Super powerful. So for like relational data is super powerful. Yeah?
I would like to add a comment in the schema of GraphQL. Because if I do the
Oh, comments?
Yeah.
I think, you'd have to Google how to comment GraphQL. I don't know how you do that actually. I probably should know that, but I don't. This one doesn't work? Just like a pound sign? Oh, here we go. Quote, quote, quote. Try that. Okay, so does that make sense? Does this kind of like data object idea? Think of it like a database. You know, this is the database, right? The entire database table. These are the values we care about. In this case, we have two different kind of objects, right? Okay, so the next thing is how the data is processed. So in this case, this is probably the hardest part of subgraphs. Just because in general, you know, it's TypeScript, basically. It's assembly script, which is a subset of TypeScript. So it's really easy to read, and it's actually got all the type safety that you would get with TypeScript. So you can kind of poke around and look around and see what's going on inside of here. But for the most part, you can understand that what we're doing is we're importing how to deal with specific types using this graph.ts package, which is already installed. If it's not installed, there's commands in the README to install it. But you need to have graph.ts installed. This allows us to define what kind of entities we care about, data types that we care about. So in this case, big ints and address is what we're importing. And then here we import the contract. So we need to import the contract so that it has all of the types for the contract so that we know how to interact with it. And then we also import the schema, which is what I just showed you guys, the GraphQL schema, which is this, because we need to know how to store those data types. And then it's just a function. So it's always running, right? Every time an event fires off, it runs, right? So you can think of it as just a always running kind of methodology. So it's listening for events. It's doing things like creating a sender string based off the event parameters that come through here. Here we do a conversion to hex string so that we can properly like convert it. We load it if it exists. If it doesn't, if it's null, then we create it and set the creation date. So here's where we actually create the very first sender. So if I'm the first, if it's the first time I've ever hit the smart contract with a greeting, it would put me in the database, right? It would put my address in from the event parameters. It would give me the created based on the timestamp of the block. So when it happened, what was the timestamp? And it would set my greeting count to 1 because it's the initial first one. Otherwise, it would increase my counter to 2. So it's pretty easy to understand. You don't need to really understand this too much, but it's just good to understand that in this case, there's one function that runs, and at the very end of the day, we store all the information for the greeting, and then we save both of them. So .save basically takes the data that we've stored into the function call and puts it and pushes it to the database. Okay? Yeah.
What is the generated folder?
The generated folder is like what is run when you run one of the generation commands. So we haven't done that yet. That's why it's showing errors. So you see how it's all squiggling? I'll show you right now. So if we go to the instructions, where are we? Okay. So first of all, I want to do local create. So I know some people are probably not being able to do this, but that's okay. We'll take a break and see if people can get caught up in a second. By the way, how long have we been going right now? Like an hour? We'll take a break soon too, so you guys can. But okay, so we want to do a yarn local create. So the reason why we're doing local create is we have to create the very first configuration for the subgraph. So you basically when you do this, it creates a subgraph inside of that Docker container, as you can see right here, over JSON RPC, and it creates the name of the subgraph and how to query it. So in this case, JSON RPC. So you just need to do that one time. After you do that, you won't need to do it again. And then we do yarn local ship. So again, we already have a subgraph that's written specifically for the smart contract. We have the smart contract. We haven't made any changes to it. It's out of the box. Same goes for the subgraph. It's already written for you. You just need to deploy it. So we're going to do that. So learn local ship. This is where we run Now, if we look at this command and what it basically does the generation. So it generates all the types that we need inside of our assembly script, because we had those errors before that were showing up here. Now you can see they went away because we had to generate the types. So it generated the types, and it also, what else does it do? It compiles down the bytecode, it compiles down the WASM into an actual binary format because it needs to be compiled. And then it injects the ABI and kind of tests it. It does a sanity check to make sure that your config's fine. If for some reason you made a change, it would tell you oh, you have an error here, and it does some linting, it would tell you how to fix that error. But in this case, it's good to go, and it should be good to go. So we're gonna do 0.0.1. So the reason why you have to put a version is because as your smart contract changes, your subgraph is probably gonna change too. You add a new function and a new event, you need to deploy a new version of your subgraph probably, because you need to add those to your subgraph. So you always kind of match your version to what version of your subgraph or smart contract. So we're going to call this to 0.0.1. You could also just put 1. You could put 99999. It doesn't matter. But in this case, we're going to do just 0.0.1 because that's what it recommends. And it's going to deploy it. So now what it's going to do is it's going to give us a URL for our data. So now we can open it up here. Okay. And here we go. We get a GraphQL browser. So now we can say, okay, let's do a query. Now what's cool about GraphQL is because we have a schema, we can inject that schema, which it does automatically for us, and we can explore the data because we already know what the data is going to look like, and it's a query language. So if we click this Explore button, it gives us all of the data available to us. So we can say, all right, well, let's say we want to get all the greetings, and we want to get the first 5 greetings or 10 greetings. We want to get back when they were created, what the greeting was, its ID, who the sender was, what their address was, and hit play. That didn't work. I don't know why. I guess, I redeployed. So let's send a greeting. Connect wallet. I'm already connected here. So let's say, hello, urbe.eth, and send. All right, cool. So now I can go back to GraphQL, hit play again, and there it is. So just like that, I sent a signature on this smart contract, changed the greeting, it ingested it on the back end, and it gave us all the data in the response. Okay? So what I'd like to do now is take maybe a 10-minute break, a 15-minute break. That way you guys can either work through your problem if you want, or go use the restroom or do whatever you want. And then when we come back, we're going to go through into a little bit more depth into the front end and kind of how you can start building your dApp. Because I also want to kind of arm you guys with a lot of front end stuff. By the way, who here would consider them a front end developer? Raise your hand. Okay, don't be afraid. A few of you guys are front end. So for me, that was the hardest thing. When I first got started, it was okay, I wrote some cool smart contracts, and how do I get my front end to hook up? And Scaffold has a lot of stuff that makes it easy for that. So what I mentioned earlier is don't be stressed out if you don't get this graph stuff working. It's okay, you can just kind of live without the graph. We're gonna kind of shift focus and try to just teach you some front end stuff after this. But I will help you guys if you want to get up to this speed. So let's take 15 minutes. If you guys want help right now, I can help, and then we'll keep going, okay? Cool. Test 1, 2, test 1, 2, test. All right, can you guys hear me? Okay. All right, so, we're gonna retract a little bit. Let me zoom out here. I don't know why this is okay, what I want to do, real quick, show of hands, who got all the way up and deployed a contract with Scaffold ETH? Who here got all the way to graph node, also got graph node working and indexing and seeing the events in GraphQL? Who here is still stuck? A couple people are stuck. Okay, so that's good. We're in a good state right now, okay? So what I want to do at this point is I want to kind of retract a little bit, and I'm going to do a little bit more like just kind of freestyle here just to show you guys some stuff, and you guys can take notes, but this is all documented. We're not going to use the graph anymore because there's no bounty for it. I don't think it's critical that we kind of dive into that too much more. I want to focus on the front end stuff, and I want to focus on scaffold.eth and how I can like position you guys to make something cool. Okay, so I'm going to reset my repository. Just wipe it out. Do a git pull. I think there was like an update while I was here. Okay, yarn install, yarn chain. Oh. I'm going to do yarn deploy or yarn start. Yarn deploy. I'm just starting over. I'm just like wiped everything out, going from scratch, getting this environment. We're not going to use the graph anymore. If you struggled to get the graph working and it's not working, I'm sorry. If it's working, that's awesome because next hackathon where the graph has a bounty, you can knock it out of the ballpark. But let's go here. Let's take a look at scaffold.eth. And let's kind of just like do some winging here. So first I want to bring up my smart contract, okay? I'm going to go into the hardhat directory, go to contracts, go to your contract, and let's just do like something simple. We're going to do like a simple change. So inside the workshop, one of the steps is we actually go through and show you how to add a new function. So here we have this thing that like, oh wait, this is the wrong thing, sorry. Where's it at? Here it is. We have you go in and add a new event, right? So let's do that. Let's create a new event. I'm just going to copy this event code over here, and we're going to put that right down below this modifier. Okay. So here we have a new event called send message, which basically is taking a from address and a to address and emitting the string that comes back from the call data, and then we're just emitting that event data. So it's easy. It's just an event, a function, and that actually all it does is emits the event. It's very straightforward, very simple use case. Basically what I'm doing is I'm sending a message on the blockchain. There's other ways to do this, but this is just, you wouldn't do this in a real world scenario, but this is just a way that we can kind of just test and see what's going on. So let's save that. And now let's redeploy. Now, one of the things you may not have saw is you can do yarn deploy reset. Reset will kind of like force your contract to constantly get deployed. So if you want to force a new contract, you can do that as many times, and each time you do that, you're going to get a new contract address, right? So if we go over here to scaffold.eth and go to debug contracts, we can see here that our contract has been deployed. If we do it again and come back over, we'll see that we get a brand new contract, okay? So reset is just kind of like a good way to just reset everything from scratch. Okay, let's grab some funds from the faucet, and now we have this new send message, right? Now we have this new way that we can send a message. Let's send a message to vitalik.eth. Does everyone know who Vitalik is? He's the creator of Ethereum, or one of the creators. Let's say, hello, what's up, dude? And hit send. So I sent a transaction. There was an event that fired off. Cool beans. It's just a really basic example of something you could do with a blockchain. So now what we can do is we can say, all right, we're going to skip over the GraphQL stuff because we're not going to do that right now. But these steps are very valuable in the future. If you are at a bounty where you can use the graph, this will show you how to create new entities, how to create new configuration in your subgraph YAML, how to regenerate the ABI and the code gen, and create the mappings, so edit your assembly script. So this is a really good thing to go through on your own free time. I just want to save time to give you guys some value for the hackathon, so I'm going to skip over this stuff. And then it shows you how to ship the new version, then you'll get a new version. What I want to show now is let's just say that we have our smart contract to the point where it's running on my machine, but now you want to publish it to Arbitrum, Sepolia, okay? Who here installed MetaMask and has like a MetaMask installed? All of you guys, almost? Okay. inside the link here, I put a Telegram channel. If you want some Arbitrum Sepolia ETH, I've already bridged like a bunch of ETH, and I can give you guys some. I can send it out later because you're going to need it for deploying. So you can join this channel, and there's a special channel for Urbe.eth bootcamp. Just paste your address in there, and I'll send you guys some. Okay? You can go and get it yourself. It takes a while because you gotta go to a Sepolia faucet, and then you gotta bridge it. So it's a little complicated. I can just send it to you. I've already done the bridging. It's gonna save you some time. So join that. But let's just say you are me, and I'm hacking, and now I want to take my smart contract and I want to deploy it. I've tested it locally. I've been able to come in here. I've been able to send a message. Cool, everything's great. What do I need to do? Well, at this point, you're all running locally. So what do I need to do first? First, what we want to do is hardhat comes with these 20 accounts, right? These are like 20 private keys that are stored there, but they're shared. Everyone uses the same private keys. So when you start deploying to a testnet or to a mainnet, you don't want to use those private keys, because the minute you try to fund an account with some ETH to pay for a deployment, it's going to get drained. There's people watching and constantly checking those private keys, and the minute there's any address that has any funds, they just drain it instantly. So you need to generate your own deployer. Okay, so you have your wallet that's in MetaMask, right? Or maybe you downloaded another wallet, but whatever. You have your kind of like user wallet. You need to generate a wallet on your local machine for hardhat to use to deploy your smart contract. So what we can do is do yarn run generate. And what this will do is it will generate a new wallet for you and store it, the private key, in an environment variable inside of the directory for you, and it will give you the address. So then you can fund this address, okay? You can also run yarn account, and it will display your account QR code. So if you have a wallet on your phone, like in my case, I could take this, I could load up my Punk wallet, if it loads, and I can do a scan, and I can scan it like this, and I get the address in here, and I can send some ETH. So it's really useful for like funding the wallet. Or you could just copy the address here and fund it. So I'm going to take this address for this wallet, and I'm going to come up here to MetaMask, because I already have 29.9 ETH, and I'm going to send to this address that I just copied 0.05. It's plenty. It's $140 in ETH, and hit next. Make sure you're on Sepolia. So I'm on Arbitrum Sepolia right now. That's where I'm sending it here. So if you want to add Arbitrum Sepolia, you can go to Alchemy, and there's a way to do it through Alchemy. You can also just type it in manually. If you just Google add Arbitrum Sepolia to MetaMask, it will give you the instructions on how to do it. Yeah, it looks like there's one here. This one will let you do it. There's a lot of different ways to do it.
There's an Arbiscan as well.
Yeah, you can do it through, what was it? Arbiscan. Yeah, so you can do it through Arbiscan. There's a lot of different ways to do it. You can add it manually, whatever. Either way, you just need to have Arbitrum Sepolia here. So what I'm doing, why did send fail? Oh, is it the same address? No. That's really weird. I've never had a send fail. I don't know. Give it a second. Anyways, I'm trying to. So what basically I've done is I've generated this account locally. There it goes. That's weird. I've never seen a failed transaction in MetaMask like that. Okay, so now I can come here and do yarn account again, and yarn account with scaffold ETH goes through and loops through and like checks all my balances for me. So in a second here, we will see Arbitrum, Sepolia, and there we go. So now I have 0.1 ETH on there. Okay. Okay. So I sent 0.1 ETH, and so now I can take my contract. we've been doing everything local. We've been using hardhat, but we've been deploying just to our local blockchain. Now, scaffold.eth has this cool function where you can just do yarn deploy -- network, and you can say what network you want. So in this case, we're going to do Arbitrum Sepolia, like that. Now, it's already got the hardhat configuration in there for that specific string to be able to deploy it to it. So it uses things. So now I've took my contract and I deployed it to Arbitrum Sepolia, just like that. So now I've taken it from my machine and deployed it. So we can go to the address here. We can grab the address and we can go to rbscan. rbscan Sepolia, let's see. Uh-oh, my internet's like freaking out right now. Okay. Sepolia Arbitrum, and paste this address in, and here we go. So there's my deployment. Yeah.
Sorry, we have to add the private key in the MD file into MetaMask.
You don't. No, because you can, but you don't need to, because you're using this is using a deployer account that runs locally, so it creates a hardhat deployer account. It's just for your terminal. It's just for hardhat. If you want to import it into MetaMask so that you don't lose the funds, you could, but you don't need to.
Yes, so it's still local.
Yeah, it's just a deployer account. It's like a temporary deployer account. Okay? Okay, so I generated a deployer account. I funded the deployer account. I deployed my smart contract to Sepolia. Here it is. It's deployed. Now, there's a couple things that you'll notice. First of all, it was deployed, but if we go to contract, it's not verified. It's just the bytecode, okay? I think I talked this earlier, but you probably learned it over the week. Bytecode is exactly that. It's not human readable. You can't read it. You need to actually be able to like instill some trust in your contract usually. That's like the way. The GUI. The GUI is to like verify your contract. So let's do that. Yarn verify. There's a command for that. -- network. Arbitrum Sepolia. Now it's going to take my contract. Oh, yeah, I had this issue the other day where it wouldn't let me do it.
Sorry, but
yeah.
Anyway, you have moved funds to the account you have created here.
I did it from MetaMask. Yeah. So basically, I already had some funds in my MetaMask, so I sent it from my MetaMask to my deployer. That's why, yeah, sorry for the confusion. Does that make sense?
Yes, sure.
Yeah, for sure. So for this part, this thing?
From deploy. For the new part.
So, yeah, so, okay, again, yarn run generate generates a private key for you to use as a deployer locally on your machine. So you don't want to use the hardhat accounts because the private key, all you guys have the same one. It's like your password. It's like saying my password's 1, 2, 3, 4, 5. So you don't want to use that. You want to create your own private key. So you run yarn run generate. If you haven't done it, it's going to generate one for you. In this case, we already have one, so it's going to tell me. Now you need to fund that account. So you need to go yarn account, get the address for it. Why does it can't connect? That's so weird. I have weird connection issues right now. The internet's having problems. But we need to fund that account. If you send me your address here, I will fund it for you. Okay? But I would recommend that I send it to your MetaMask so that you can send it because you might generate more than one deployer. So
from my MetaMask, I have to send that.
Yeah.
The new, okay.
Yeah. So if you need ETH, you don't need to do it right now. I'll give you guys some ETH later. I'm just really showing you like how you get your contract to Arbitrum. You also don't have to verify your contract. So if you notice, I just had an error. There's a way to do it without using the Etherscan. I think it's yarn. So I think it's, let's see, hardhat verify, let's see, rbscan Sepolia URL. Let's see if this works. Here we go. Let's try this. Dash API dash. Does that make sense? Okay. Let's see if this works. Did it work? Let me try this. I think I need to just remove this right here. So basically, like, what the yarn verify command does is it takes your contract and it gives the source code to the Etherscan or RBScan. RBScan is basically like a block explorer. So it indexes, it's kind of like what the graph is, but it's a centralized solution. It indexes everything and then makes it browsable in a UI. The reason why you would do something like this is because you want to take your source code and you want to provide it so that they can take the copy of it, compile down the bytecode, and make sure it matches what's on the blockchain. So basically, they're just like checking your work. And once you do that, your contract will then be verified. So if we hit refresh, maybe it worked. Let's see. It's not working. I don't know why. Yeah, that's probably what it is. You're right. I probably need credentials to verify it. Let's see. So in this case, 404. Let's see. Just curious. That's 200. Yeah, maybe we do need an RBScan like API key. That could be. So if you want to verify your contract, again, I'm kind of like getting into like nuances here. You don't need to verify your contract. I'd recommend it because in the future it's just a good thing to do. If we get stuck here, that's fine. But let's go home. Let's see if we can Arbitrum Sepolia. Oh, maybe it's this one. Let's see. Oh, I know. We could probably do it with Alchemy, actually. So Alchemy is like a toolkit for, they provide like a JSON RPC. They provide a entry-level like way into the blockchain if you don't want to use like your own node, if you want to run your own node. So I think you can actually like do it this way. Let's see. API key. So you can actually create an API key through them. So here's the API key, and then you can do the URL. Let's try this. Let's just see if this works. So we can do yarn verify -- API URL and paste in this one, which is with my key. Let's see if that works. It's 404. Why is it giving me a 404? I don't understand why that's not working. That should work. Okay, I don't know. Either way, there is other options. So you could submit your source code manually. For right now, let's skip over that because I want to get you guys kind of moving on more of the functionality. So we've deployed our smart contract to Arbitrum Sepolia, which is good enough for you guys to qualify for the bounty. It's been deployed. We verified that because we went here. We actually see the transactions. We see that it was deployed 5 minutes ago. Now let's look at our front end, okay? So everything I've been teaching you guys mainly has been around the back end, the middleware, but now we need to get a little bit more into the front end stuff, okay? So the first thing is, we're not gonna touch the smart contract anymore. We're gonna focus on Next.js, okay? So inside of Next.js, we just migrated to the app router. So what that means is that there's this app folder, and I personally like it. It's a little more intuitive. It uses a directory approach to mapping your URIs, your URLs. So in this case, we have a main app. Instead of using index.tsx, it's called page. So if you're not using app router, it's usually index.tsx or TS or JS or whatever. In this case, it's called page.tsx. So the main page of scaffold.eth is right here, okay? And just to show you guys, I'm going to load up scaffold.eth here. go to the home page. You can see all this stuff here. This is exactly what we see here. So I'm just going to wipe some of this stuff out. Let me just show you, because this is what I'd recommend you do, is just dump all this like stuff. Just get rid of all this and save it. And then that's going to wipe it out there, right? So this is where you should start, ground zero. Leave this the way it is. Leave this the way it is. You can change it if you want as you get further in your project. But for right now, you're probably going to need the burner wallet. For right now, you're going to need to be able to do debugging. You know, when you start polishing your app, you can like move stuff around and get rid of the logos and put it up. But keep it like this, and then build your app inside of here, basically. You think of it like an app within the app. So build it in that main page. Yeah.
So the nav bar should remain the same.
Yes, so the nav bar is inside of the components, basically. So components here, we have the header and the footer. So if we look at the page, we can see, and I always forget how this goes, but there's like a layout. And these are the children, and then, yeah. I'm still a little green to the app router and how it works, but yeah. Basically, the header and the footer are going to be loading, and they're right here, header and footer. So here's the header, which is the URIs. So here you can see we have the home, which is the root, which is here. We have the subgraph, which is here. That's here. And then we have the debug contracts, which is here. So you can see here there's a bug ant icon. Here's the bug. Here's the magnifying glass right here, right? So you can start adding to this later, the headers here. And then same thing goes for the footer. This has like the faucet, the current ETH price. ETH is up. All right. Yeah, so basically we're going to build out here. Okay, does that make sense? Any questions so far? Good? Okay. So you can see here we got some stuff that's grayed out here. Like we don't need these things. We can take those away. We don't need link. We're not using that. We can save it. Let's make sure it still loads. Okay, so what I want to get into first is just the configuration. Right now, we're still pointing at hardhat. So inside of the root of scaffold.eth next.js folder, there is a scaffold.config.ts file, okay? And this has a target network configuration. So what we need to do is change this from hardhat to Arbitrum Sepolia. So Arbitrum, if we start typing, it picks up the types automatically because we're using TypeScript. Everyone, remember that? Use TypeScript. So Arbitrum Sepolia, there we go. So I can just click it, it knows what type I want to do, and I can hit save. So it's under scaffold config, target networks. Now if I go over here, you'll see I got wiped out. I got knocked out of my burner wallet. That's because we don't want to use a burner wallet anymore. We're on a public test net. We need to use something that's a little more secure. This is where it's like, okay, we need to use MetaMask, right? We've secured our private key, all that good stuff. Don't share your private key, all that good stuff. We could use Rainbow. We could use a hardware wallet, whatever you choose. We're going to use MetaMask because it's super easy. And here we go. Now I'm logged in. I have my ENS name. It shows me I'm connected to Arbitrum Sepolia. I have my 29 ETH. And now I can start interacting with my smart contract. So I could say, okay, cool, well, here's my contract. Is that right? This is 0x173. Here it is. Is that right? Yeah, 0x173. So my contract's been deployed. If we actually look at scaffold.eth and we go to the contracts, here's the deployed contract. There's the address for it. Oh wait, that doesn't look like it matches actually, but that's okay. So it's working. Now we can propose a transaction. So now let's send Vitalik another message.
But we have to connect the wallet when we...
I already did up here, yeah, but you'll need to. So you'll have to like, if you haven't connected, it'll pop up like this. You click that, and then go to MetaMask, okay? Yeah. Okay, so let's send Vitalik.eth a message. Say, cool cat. All right, hit send. Now it's going to be a little different experience. We're on a public test net, it's a little slower. I have to actually approve the amount of gas that's going to be sent. So it's going to cost me $1 in Arbitrum Sepolia ETH. I can confirm that, and I can send it. Now it's going to mine the transaction. It was successful, and now it's good. So I can also update the greeting to, I don't know, like urbe.eth is the best in the West. No, that wouldn't make sense. I could hit send. Boom. Now, I want to touch base on one thing that I didn't really cover earlier. I don't have enough ETH. Yeah, I do. Okay, I'm having some weird stuff with the network. I don't know what's going on. But that's okay, it worked. Let's see if it worked. Okay, urbe.eth is the best, so it worked. It let me change it. I don't know what that was about. Anyways, I want to focus on one thing, and I didn't really cover this, but I think you may have done it with Mateus. We've deployed this contract as this owner. 0x17, wait, is that right? Oh, okay, this is the owner. Yeah, so this is the deployer contract. So this is the contract address, sorry. So the contract here is here, 063. That's why I didn't match it earlier. Oh, 062, okay. So yeah, so our contract, one second. Our contract address is here, right? That matches here, right? The address owner though, that's the outlier. That's the problem. That's the thing I want to talk to you about. We are using the default deployment script of hardhat. So if we go to hardhat and we go to deploy, there's a deployer contract script. And one thing it's important to know is when we deploy our contract, let me scroll down here. When we deploy our contract, we pass an argument with the deployer, and we get the deployer right here. So deployer equals await hre.getNamedAccounts. So it's going to take the very first hardhat account and use that to deploy our smart contract. There's two ways that you can take control of the contract. Because we're deploying to a testnet, you should want to take control of the contract. There's actually three ways. The first way is I could grab this private key and I could transfer. The TV went off. Excuse me, the TV went off. So there's a few ways that you can do this. So the first thing is we can manually set. I don't know, maybe it was I moved something. There's just too much power being drawn from my computer. I can set the argument here to wherever I want. So if I wanted to, I could pass my address here. So I could copy my address, and I could do it like this, like that. And I could just send my address over. That's one way. Another way is I could write some kind of script that uses the transfer function to transfer the owner. I would probably say that you could just put in the address here that you want the owner to be. That's the easiest way. The other option is we could, I'm trying to think what's best practice. Anyways, there's lots of different ways. I would probably just use this one, it's easier. So you can just paste your address in here. We're not gonna mess with that right now because I've already deployed the contract, so I kind of want to move in, but that's just important for you guys to know that you'll need to do that. Okay, so now our application is working. We've been able to set the greeting. We didn't transfer the ownership. We probably should have. One thing we could do, actually, that is probably a cool thing, is we could actually redeploy the contract if we wanted to using Ownable. So has anyone heard of OpenZeppelin before? OpenZeppelin? Okay, so OpenZeppelin kind of creates like industry standard subgraphs. And inside of our smart contract, I'm kind of jumping around a little bit, but I just want to mention this, is the ability to import OpenZeppelin. So it's kind of already here for you, ownable.sol. Now the thing about this smart contract that you get with Scaffold ETH is it already kind of comes with an access control pattern. So you would need to kind of gut it a little bit. And so that would involve you doing things like removing the constructor address here, doing something like this, removing that, removing the modifier. There's a lot of things you'll need to do to get it kind of to the point where you can use Ownable. but I just want to mention that I would recommend you do that because ownable is kind of like the industry standard way to do access control. And there's also a function in there called transfer that allows you to transfer the owner of the smart contract as well. So the proper way would probably be to do that. Just for the sake of time, I don't think we have time to really go too much into that, but I would look up how to do that. It's really easy. Like I said, you'll need to probably change your smart contract. The chances are you're not going to use this smart contract. You're going to start from scratch, right? So let me just do this real quick, not save. Okay. So let's say we've upgraded our front end a little bit here to point at. We've been able to kind of update our greeting. We've been debugging our contract. We've been doing everything locally. Now we want to start building out our UI, our user interface. Yeah. Oh, sorry. Yeah, I know you had a question. Sorry.
I have a problem. How do you change the Arbitrum for your network?
Yes, it's in the scaffold config. Yeah, so it's inside of applications, packages, Next.js, and then it's the scaffold.config.ts, and it's here, network, target networks, chains.arbitrum sepolia. Yeah. Okay, so at this point, I want to just start talking about the front end stuff. So inside my README, I kind of give you all the stuff you need. Sorry, it's this one here. The main things I want to talk about with scaffold.eth is scaffold.eth uses WAGME, which you can use basically WAGME to get like the account that's connected. And then we have all of the hooks, and then we have all of the components of scaffold.eth. So those are like components that we wrote that make it easy, and we're going to go through them right now. And then there's some additional stuff in here in the README that will teach you this stuff. So those will be your like best friend if you're building on scaffold.eth, which you have to. I did it again, sorry. Okay, so we'll wait for it to load real quick. It's here, so I'll just give it one more sec. Sorry, man. I don't know, I heard they touched it, but. Okay, there it goes. Okay, so I give you all the configuration of what it should look like. Basically, we're going to start out with kind of like this here. So let's do it one by one. So we've kind of already kind of wiped out all the center text here. But what I want to show is here kind of what we're doing. So let me just grab all this stuff. So basically, and we're going to paste it into this page TSX file. Why did that not work? Import type. Oh, I have it duplicated, that's why. Okay, so we can put this one up here. Okay. So basically, with the VS Code, it's going to tell you what's being used and what's not being used. So obviously, we're not using anything here, but we have it all imported, and there's no errors. There's this little weird one, but WAGME always does that. I don't know why. The first thing that I'll tell you about is this use clients. So because we're using App Router, I think App Router is kind of considered experimental. It's not mainstream yet. And more importantly, it doesn't support by default, the ability to do use state. I don't know why, but there's some kind of issue with it. So you have to tell it specifically to use client. So that thing on the top is kind of like a Band-Aid. So more importantly, if you add subpages and you're trying to use state, you might get an error. And it's very hard to understand what the error means. But you basically need to tell it use client if you're going to use any kind of state. So React, uses state, and obviously Next.js is built on React. So we're going to use state from React. We're also going to use Apollo client. Let me make this a little bigger. We're going to use Apollo client if we were going to use like the graph, because it's GraphQL. We're actually not going to use that. We can just kind of get rid of that. We're going to use query. No, we're not. Sorry. Let's get rid of that. We're going to use WAGME to get the address. So we're going to import use account from WAGME, which allows me to get the address. We're going to import the components from scaffold.eth. There's a bunch of them, but the ones that I'm going to show you today is address, address input, and balance. So these are all like, one is like a really cool way to display the address in a nice, like, pretty way. One is the way to like import the address. You know how earlier when I typed of italic.eth and it converted it to his PFP and it showed me and it did the ENS resolution? That's what that is. So it's automatically doing all that stuff for you, which is really cool. Because otherwise you'd have to write all that in the code. The other thing is the balance. It will actually go out and query and get a balance for an address using balance. We're also going to be able to read from our contract and write to our contract by using these hooks. So there's a balance one, there's a use deployed contract, and then there's a use scaffold contract read, and there's use scaffold contract write, and I'm going to walk you guys through each one. Okay, so the first one, and again, this is all in this documentation. What we're going to do is you define a new div. So in this case, we're going to add a div like right below here. If you, you might need to do some like formatting to make it pretty. I have an auto formatter. I don't even know what I use. Maybe it's prettier. I think I use prettier. So here we have a div. So div, if anyone doesn't know, it's basically like a divider or like a group of any kind of like content you want to do. And so in this case, we're going to create a div, which is a container basically, with two things, an address and then a balance. And we need to define where those addresses for each of those components is coming from. And so you can see here we get this squiggly mark because we don't have the address. So how do we get that? So we need to do that here. So we can do const.
But the page that we have is different from yours.
No, it's not.
Okay, I have to erase.
Yeah, I just haven't done it yet, yeah. So it gives you what we need here. I was going to type it manually, but here it is. So here, what we're doing is we're using WAGME. So WAGME is here, use account. And the cool thing about if you're using VS Code and you're using types is you can do something like this. And you could say like, what are we going to do? Const address. I'm also using Copilot, which if you guys aren't using Copilot, man, it's amazing. You need to use it. So equal, and then we're going to do use account. Now, if I do use account, it's going to automatically import it for me. You see that? It just popped in here. So that's really useful because it knows that that type exists, and it's going to automatically import it for me in VS Code. But that's fine. We had it up there before, but now it's down here. Sorry, this is not right. So there we go. So now I hit save, and let's go to the front end. Oh, there's an error. There we go. Cool. So I am getting the address from the connected wallet, which is use account, and then I'm displaying the address here in this little pretty thing. It has got a copy button, which is cool, because if you just want to copy that. And then it also we have the balance right here as well, which is passed along in the component as an address. So there we go. We're starting to kind of build out like a little basic UI. By the way, this UI is not going to be pretty. I am not a front-end developer. I'm just showing you guys how to do it. Yeah.
The CSS of the things we're seeing are automatic, or you have?
Yeah. So as far as this stuff goes, these class names. That's a good question. These are all from Tailwind CSS. Yeah. So if you want to do anything with Tailwind, you can. But yeah, that's what we're using.
How you haven't typed it manually?
Yeah, I just copy paste this stuff in. But it will discover it because it is in, like, let's say you did PT, I think PT dash, oh, maybe it doesn't. I thought it did. Yeah. Oh. Control space? Ah, there you go. Thank you. See, I'm not a front-end guy. CSS, I just like, goes way out of my... Yeah. Okay, anyways, so you get the idea. It's working. Okay, so now what else we got? We can go down. So now we've added an address and a balance component. Let's also add the greeting, the current greeting. So here we'll add another div. We'll put it right below here, like this. And we need to get this data. So we want to display the greeting. I already put the CSS there because I'm not going to do that in real time, but we need to actually get the data. So in this case, we can do that using this function here. So it's going to be, we can just grab it up here. So what this is doing is it's giving us the ability to grab the data as a greeting object using scaffold contract read. So scaffold contract read, if I was to, I think, hit control or just hover my mouse, it will tell me what I need to pass there. So in this case, it's telling me I need the contract name and the function name, and it can also take arguments if there's arguments required, right? But in this case, we just want to get the contract greeting. So that's going to match exactly what's in our existing contract. So here it is, and it's called, what is it called? Your contract. So the contract is here, your contract, and then the function name is greeting. So there's a getter function for the greeting, and it's right here. So the getter function for a read is greeting, so it's greeting. So we're just passing in the contract name and the greeting. So if we had multiple contracts, you would need to specify if it was a certain contract. In this case, we only have one contract we're deploying, and we have a function name called greeting. So if we hit save, now this error went away, and now we can go back and look at that in the front. There it is. So now we have the urbe.eth is the best that we're getting from there. Any questions?
Can you come back on the code?
Yeah, so basically we're just doing, so we have a separate div for the address and the balance. Then we have this new div, which is getting just the greeting in this like response variable syntax, just like whatever, like raw data. And we are passing, we're passing in the value of greeting as a data object here. So we're getting it into a variable using this hook. So use scaffold contract read is for reading information. The contract name and the function name are both the required fields to be able to read the data. Okay? Okay. So now let's pretend we want to, we queried the connected wallet. Now we want to query like another component. In this case, we want to get the contract balance and the contract address. So how do we do that? So we have a new div here. So let's put that right below this one. And in this case, we need to define where the contract is coming from. So in this case, we're trying to get the contract's address and the contract's balance. So how do we do that? Well, it's right here. There's a hook for it. So we can paste that in right below. Now what this one's going to do is it's going to, same thing. It's going to allow us to have some data that comes back. In this case, it's called your contract that we want to name it, which is what we need here, right? And then we're going to use deployed contract info and pass the contract. So just like we did before, we can hover our mouse here. It tells us what we need. In this case, it tells us exactly what we need, which is the contract name. So in this case, it's called your contract, and then it shows us what the types are and all that good stuff, which is really useful. Everyone should use TypeScript. That's why it's so easy. And then we can save that and then come here again. And now we have the current connected wallet on the top. Then we have the contract address and how much balance it has. So if I was to come over here, grab this address, and then send some ETH there, let's go send. Let's paste the address, and let's do 0.005 ETH. Hit next. Hit confirm. Come back over here. There it goes. Now it has ETH, right? I sent it some value, so now it's pulling from the contract. Okay? Cool. So now we've got this way to read from the contract, read from the connected wallet, read from a certain function. So now let's say we want to do something a little more. Let's say we want to create an input field and change the greeting. Okay? So it's getting a little more technical here, but for the most part, I'll walk you guys through this. We're going to add another div here. And this one is going to have an input field. So we have an input field where the value is going to be a variable called new greeting. So it's the greeting I want to set. It's going to have a placeholder, which is just like empty space. So type here, it's just going to say that. It's going to have a class name of input. And then this is where we start to use state, because as the user's typing in, right, in the input field, we have to keep track of that somewhere. So this is where we say, okay, well, we can store that in state. And then we have a button that basically will allow us to update the state. So in this case, on click, we will set greeting. And this is the name of the button, set greeting. Okay? So to get that, it's a little more complicated, but it's right here. I'll walk you guys through it. Is we can say, okay. So first of all, I mentioned we need to use state. So as the user's typing in there, whatever is in there, we want to keep track of that in a state. So we start the state as empty. So as we start out with nothing. Nothing's in state. Then we set a new greeting, and then a way to update the state based off the, a way to set the new greeting based off the state, basically to pass it. So here we do a write async that allows us to set the greeting. And then we use the scaffold contract write function. So earlier we just did a read to get the particular variable that we needed back. Now we're actually going to call a write function. So this is a transaction. So this is going to use, I think it uses VM under the hood to formulate a transaction and actually submit the transaction. So this is like a wrapper around VM. So you don't need to know VM. You could just write everything in VM if you wanted to. It would support that. But I recommend using these because they're already written for you and they're easy to understand. So in this case, we have a contract name called your contract. It's the same, right? We have a set greeting function, right? We have the greeting function here is to read. This one is to write. The only difference is that this one requires arguments because we actually need to pass the greeting. So what is that greeting? It is the new greeting that's in state. So whatever is in state, the minute that this gets hit on that button, which is here, on click, set greeting. So it's going to call the set greeting, and whatever's in this state, new greeting, is going to be set. So it passes it through. Yeah. Where's the what?
Where are the functions declared or implemented? Where are they?
The functions, they're inside of components. Well, now I have to look, but let's see. I think we can actually look here. Oh yeah, here's hooks. Yeah, control click, right? I don't know why it's not working.
Or maybe command click.
Oh, command click, yeah. So here it is, yeah. So there's the scaffold ETH folder. Here's the address, balance. Yeah, so if you want to see what they're doing under the hood, you can kind of come in here and see. Yeah, so hardhat VM. Yeah, I don't really, I have not dived too much into this stuff. I mean, I kind of know it at a high level, but anyways. Okay, any other questions? No? Okay, so now we should have this new fancy button where we can set the greeting and an input field. So we can say like, hey, urbe.eth is here to stay. I don't know. Set greeting. Now it's going to formulate a transaction, send off the transaction. I just need to sign it, and then we're good. Right? So now it should have updated. If I was a good developer, I probably would have stored that thing in some kind of like event. Oh, there it goes. So there it goes. It works. Okay. So what else can we do? So now we can do a send message. I'm actually going to skip that one because it's the exact same thing I just did. You guys can do it if you want, but it's going to allow you to do a read and a write. So in this case, we just have two things that we need to keep track of because we have an address input that is who the message is going to. We have another div that keeps the input field for what the message is going to be. And then we have another button that allows us to send the message. So it's using the same kind of like functions that are here, which allow us to send a message right here. But it's going to input it. I'm going to skip that one because I'd rather you guys start trying to do this stuff. And then if you get stuck, let me know. And then this other one I also am going to skip because it's the graph, but super useful is if you want to know how to read data from the graph, this walks you through exactly what you need to do using GQL and use query and how to get the data into an object. And there you go. And this is where it tells you how to ship to a test net. So here we say yarn run generate. So these are all the commands I ran earlier. Yarn run generate, yarn account is where you get your count. This is how you do the deploy. This is how you do a verify. If the verify doesn't work, there's a way to do it with the API key, and I'll try to give it to you guys, and I'll message you guys in the chat. Don't be too worried because you got to provide your source code anyways to the urbe.eth team. But in general, you should verify your contract. For some reason, Arbitrum Sepolia just doesn't work out of the box. If it was Sepolia or Guerrero, it would be no problem. It would work. Okay, so I want to give you guys a chance, and I also want to see if you guys have any questions. So why don't you guys try to go through and make some UI changes. It'd be cool if you made them all, but if you guys want to at least just give it a whirl, and then if you get stuck, let me know. And then I'll close up just the last 50, so we'll do this for like 10 minutes, and then I just want to close off talking about our Graph Advocates program, and I want to talk about Build Guild and how you guys can get involved, okay? Any questions? Yeah?
Can you repeat how do you set your own private key in order to deploy with it?
Yeah, so you just run yarn run generate.
No, I mean private key I already have.
Yeah, you could, I guess you could do it. Yeah, I think, yeah, so, I mean, I could show you, let's just, yeah, so I think if you edit this env file with your private key, then it should work. So if you could, it does work, yeah, it should work, yeah.
Okay, because I don't know if I have to set it like we already said on the previous lessons, say that, or there's another structure.
Okay.
So I just modify the .env file.
Yeah. I'm going to check the chat folder right now to see if anyone needs Arbitrum ETH, and I'll send you guys some. So make sure you join that. It's under here. Graph Builders office hours. Oh, sorry, now here. Graph Builders, Urbe ETH. And then here's, okay, so I'll send some here.
Which channel on the graph? Urbe.eth.
Say that again?
Sorry.
Oh, okay.
Which channel on the graph builder?
Yeah. What's the, sorry, what? I can't hear, sorry, man. What?
The GitHub with your...
Oh, my GitHub? It's KM Jones 1979. KM Jones 1979. Did you have a question? No? You good? No questions? No? You good?
Why this outlet is red, but but
I don't know.
always
I don't know why it's doing that. Yeah, it works. Yeah, I'm not sure. The other day I noticed that and I haven't been able to figure it out.
So it's okay like that.
Yeah.
Okay.
Yeah. All right. Anybody have questions? Where can we get what? Sorry, really hard to hear you. What? Slideshow. It's in the slides are inside the doc as well. So I think I linked them. So yeah, if you go to here, the slides are up here. Yeah, if you can't access them, let me know, but it should work. You had a question? Diagram?
Yeah.
Which one?
For the token. For the
Subgraph?
yeah.
It's in the slides. Yeah. So if you go here to this, there's slides are at the top right here. Okay. Was there? You talking about the diagrams I showed in my slides? Is that what you're talking about?
Oh yeah.
Up. There you go. Is it not there? Did you try refreshing it?
Yeah, just.
Oh, here it is. There it is.
Okay.
There you go. Yeah, let me know if you can't access slides. Any other questions? Any other questions? No? Cool. Couple more minutes and then I'll go into the last kind of section. Excuse me. Anybody stuck at all or having any issues? No? Cool. You guys are awesome. You guys are really killing it. You guys got through everything. I applaud you guys.
Infatti leggevo che tu dicevi insufficienza.
Tocca leggere gli errori. Che no?
Era tutto che io ero pure uno, magari mi sono pure uno più.
I'm going to send off this ETH for you guys right now, and then I'll get started on the next part, okay?
Sorry, so every time we do a transaction, we deploy a contract, we work fees, but it's like...
It's gas, yeah.
Yes, like 1 and 20 cents. Isn't that high?
Yeah, so that's a good question. I will address that in 1 second. Hold on.
sorry, you're an editor of the file because I have to change one thing here.
What do you need to change? Oh, like you do? Oh, because of your steps?
For my token for the exercise of yesterday.
Oh, talk to, what's his name? He's the owner, actually. Okay, so good question that someone just asked me that we didn't really talk about probably much in this is gas, right? I think you guys like briefly touched on gas probably a little bit. Yeah, gas is kind of expensive in the terms of like, you know, when you make a state change on the blockchain, you're actually like submitting that to all of the nodes on the network. Yeah, if you guys can just bring it down just a little bit. So, you know, you're basically paying for the security of the network, right? So yes, it's expensive. There's lots of things going on to like try to lower that. Some of the things that they want to do is like sharding the blockchain to make it to where like maybe you don't need to like replicate that stuff across all of the network. Yeah, there's some other stuff that like they're thinking about on like scaling wise, like how they can make it cheaper. One of the things that did help is like the most recent, I forget the EIP number, but the thing that allows like burning, which basically increases the gas fee and burns ETH, so it kind of incentivizes people to wait to do their transaction. There's also layer 2s, which are a lot cheaper. So a lot of people are kind of like saying, okay, well, we should probably scale like apps that are like more like frequent updates will require more transactions to a layer 2 network like Arbitrum, which is a lot cheaper. But yeah, I guess it does depend on what you're storing and the size of the call. Try to store stuff off chain if you can on like IPFS and Arweave. Only, you know, change state for things that you really need to. That would be my advice. Yeah. Okay. I want to talk about a couple things. First of all, is the Graph Advocates program. So the Graph Advocates actually funded for me to come here today. It's part of the core part of the Graphs community. And essentially it's an advocates program that anyone can join who is like kind of passionate about the graph. So if you guys were interested in getting involved in like Web3, it's kind of a good way. It's a pretty good community of people from all over the world. Paolo, who is like the community manager for the Graph Foundation, is here in Rome. He was here a couple days ago. I don't know if you guys saw him. I think he'll be here tomorrow. Really cool guy. He's a great resource if you actually really want to get invited into the community and like kind of learn. If you guys could bring down the volume just a little bit. There's different things you can do. You can be an event evangelist, so you can actually like host events, kind of like what we're doing today. You can do online stuff if you want to go a more broader community. You can also be just a content creator. So if you want to write blogs, you want to do workshops, you want to create videos, like if you're passionate about one specific thing, a podcast, whatever, there's different ways that you can get involved by creating content. If you want to translate documents that are, you know, maybe developer documents or docs or social media posts that are in another language, if you're bilingual, you can get involved there. You can also do things what's called community care, so you can just kind of like help out with like the community, being active in Telegram, Discord, the forums, stuff like that. Or you can be like something like a technical teacher, like also like me, where we're actually like getting into the nitty gritty and like teaching people and teaching people how to use the technology. Okay. Any questions about that? Yeah.
It's about the graph in general. It could be used like to. Let's say we have a Web3 game, like to drive charts, statistics regarding the players and things like this.
Yeah, I mean, technically you could store, so you can index anything that is on chain, that's a supported chain, or anything that's in IPFS or Arweave, so like static files. Images, there's been some like experiments where maybe you could like put some images and some HTML and CSS. Definitely could do it with like SVG, because you know you could like render the stuff. But yeah, it's a cool idea actually.
But regarding IPFS, the first thing I think about is the URI of an NFT.
Yeah.
That includes an IPFS.
Yeah.
I would like make statistics regarding trades using the graph?
Yeah, you could do that. Yeah. There's a lot of NFTs. Like if you look at the CryptoPunks example, that's a good one to look at because it references all the traits that are on IPFS and ingests those, I believe. So there's a CryptoPunks. If you go to thegraph.com/explorer and search CryptoPunks, there's one on Arbitrum that was written by Jerry Ocolo, I think his name is. He works for the Graph, actually. He works for EdgeNode. And that one, I think, does that. It does does data lookups for all the traits, and it also indexes the event contracts, and it has a lot of stuff in there where you can do it.
Okay,
Yeah.
a lot of stuff regarding how the CryptoPunks pass from wallet to wallet.
Yep. Yeah. So basically, like the graph, we talked a lot about the graph today. The graph is, for indexing decentralized data, IPFS, Arweave, and events from Ethereum. There's also some other cool stuff, like you can index all the data from the blocks as well using what's called totally blanking right now. It's called substreams. I don't know what's wrong with me today. Firehose to substreams, which allows you to parse really detailed information that are in the ordinals of a block. So there's actually a lot of flexibility on the data you could get from Firehose as well. Firehose and substreams.
For example, getting the holders list by number of something is not so easy on the chain.
Yeah.
Or you have a service that allows you, or else you can make yourself with the graph.
Yep. I just want to show real quick for Graph Advocates, if you guys are interested, all you need to do is go to graphadvocates.com and apply here. And you fill out this form and someone will contact you to set up an interview and then kind of how you want to get involved in the community. You don't need to be an expert on the graph to do some of the jobs. And even if you're a new, I would recommend it. The other thing I want to talk about is Build Guild. Okay, so if you get through this hackathon, which you all are, I want to see you guys submit. After you're done, this should be where you go. Speedrunethereum.com. Who's here has heard of this? Okay, Speedrun Ethereum is the best way to kind of test your skills. This is built by Austin Griffith and the Scaffold ETH team. So it's all built around Scaffold ETH. So you use Scaffold ETH to basically go through these challenges. And you kind of test your skill. The first one is you deploy an NFT. It's really easy. The second one, you go through and you deploy a staking app. So you learn about how to stake your tokens and how to get back, something. Then you also build a token vendor, which allows you to basically create an ERC20 essentially. Then you join the Build Guild. So this is what I wanted to mention. So once you join, can't join the Build Guild. That's funny. I am in the Build Guild. The Build Guild is a cool concept that's blows my mind to think how much the Build Guild is actually involved in the ecosystem. Basically, it's decentralized developers that are actively building on Ethereum. And there are people that are building these different challenges, building products. There's core developers that work on Scaffold ETH too. There's people like me that do evangelism. But it's all built around the concept of Scaffold ETH too. And there's a lot of cool projects that have spawned out of this. One is ABI Ninja, address.vision is really cool. You can click here to see all the projects that were built on Scaffold ETH if you guys are looking for some ideas. But this is the cool part. 703 ETH has been streamed to the developers for doing active stuff in the community. So it's a UBI kind of model where if you're a developer, you go through, you join the Build Guild, you show your work and you show how good you are at building on Ethereum or building dApps, you can actually get invited to the Build Guild and get a stream if you're good enough, and we can incentivize you by paying you a stream to do things in the ecosystem, okay? So there's over 1,000 builders. I think it's more actually. There's about 30 or 40 that are kind of core builders. And then there's over 1,000 different builds of Scaffold ETH that have been submitted as examples or use cases. So there's lots of ways that you can kind of get a real tap on what's going on with developers. Integration with something or a use case of something new that's coming out, like account abstraction or whatever it is that you're passionate about. And then once you join, you can basically be in the Build Guild. and you get upgraded and you have your own little profile. If you go here to here, you can see all the different builders, how much ETH that they're streamed. Everything's public available. These are all smart contracts, by the way. So all these smart contracts are available. So I highly recommend you guys check that out. All you need to do is go to speedrunethereum.com and join that.
Do you have your own punks?
Yeah, it's like a punk wallet kind of concept. We just generate like a punk based off the address. Yeah.
Okay.
So it's not a punk. It's not a crypto punk. It's a build guild punk. Yeah. So if you see like I have one, I don't even know what mine is. Mine's weird. It's got pink hair.
on the public key.
Yeah, it's based off the public key. Yeah, there's also Punk Wallet, which is really cool. So like I was showing you earlier, is like Punk Wallet you can load on your phone, and it's got like a QR code scanner, and you can like scan the QRs and have it's a browser-based wallet. It's not super secure, so I wouldn't use it like for mainnet funds, but it's good for like developer testing and stuff like that. And there's some other apps, like we actually built another wallet. There's a Scaffold ETH wallet too. So there's a lot of cool stuff with Scaffold ETH.
I got a good punk.
Yeah, you gotta join, you gotta join. Okay, so we did a lot today. We went through the full stack dApp stuff. Talked to you guys about Speedrun Ethereum. I sent you guys some ETH. I'll be around to help out. I think tomorrow we're gonna do team formation stuff, and what else? What else are we gonna do tomorrow? Some thinking, yeah. So tomorrow's gonna be good because we're gonna talk to you more about like, you know, how you can really like build something cool. Yeah, excited to help you guys out. Does anyone have any more questions that I can answer about the graph or Scaffold ETH, or even just questions about hackathons? I go to a lot of hackathons, so happy to help you out.
The hackathon is a guideline, or is like I can do whatever I want?
I think the main rules are, I mean, he talked about earlier, is like you need to use Scaffold ETH. You need to deploy to Arbitrum, Sabolia. You know, it should be obviously a smart contract that you make changes to, a decentralized application.
Nothing too specific.
No, I don't think there's no rules for what kind of products. It's not like you have to build this kind of an app. Just as long as it's a smart contract, it's deployed to Arbitrum. You use Scaffold ETH. You know, yeah. Cool. Any other questions that you guys have? No? Yeah. So the last thing I'll say is like everything you really need to like kind of get going and up and running should be in here. You can literally watch this video and like replay if you get stuck on anywhere with the stuff. There's tons of videos on Scaffold ETH. A lot of them are me or Austin Griffith. So if you get stuck, just look on there. We also have a Telegram channel for just dedicated to Scaffold ETH. So if you, I think it's in here on the bottom. Let's see. I'll post the URL. So it's or maybe it's on here. Let's see. Support. Let's see. Yeah, there it is. So if you go to scaffoldeth.io, go all the way to the bottom, and there's this support button right here. That will open up the Telegram chat. If for some reason I'm not available because, I don't know, I'm asleep because I'm jet lagged, you might be able to get help in here. There's like 2,000 developers in here. So if you guys get stuck with Scaffold ETH, come in here, post your question. And yeah, I'll also try to invite a couple devs into this Urbe bootcamp thing as well to see if you guys have questions there. You can ask as well. But I really just set this up so if you guys have questions about the graph in the future. So cool. Thank you guys so much. You guys are all awesome. Thank you. Thank you.